So the today's topic is Hill Cipher. So the Hill Cipher comes into the category of block cipher. So there are two types of categories: the block cipher and the stream ciphers. So what are they? The thing has will be discussed in the further coming lectures. But for the introduction point of view, in the block cipher, we have to encrypt the plain text in a block nature. Like suppose what the previously we have done, that the plain text is divided into the streams. So P1, P2, P3 and P4 and so on. And one at a time I have to select only P1 for the encryption process. Then for P2, then for P3 and P4. And according to the that scenario, the ciphertext will be generated like corresponding to P1 encryption process. C1 will be generated, C2 will be generated, C3 and so on. But in the case of block cipher, we have to encrypt all of the block at a time. Like suppose if your plain text is P1, P2, P3, so instead of doing the encryption one by one, position wise like P1, then P2, then, then P3, then P4, you have to encrypt all of the block at a time. Okay, so that is the main difference between the stream cipher and the block cipher. So Hill cipher is known as or belongs to the block cipher category. So what is the block cipher? The plain text is divided into the equal size block. So suppose this is the one block, then the another block will be P5, P6, P7 and P8. Like this one. This is a block 1 and this is block 2. So in the block cipher, the plain text is divided into the equal size block. Now each block is encrypted one at a time. So parallel encryption nahi hoga. First the block B1 will be encrypted, then block B2, then so on. So the block is encrypted one at a time in such a way that each character in the block contributes to the inscription of the character of another block. Right? So here cipher says first we have to do the encryption of block 1. Then this block 1 encryption will contribute to the encryption process of block B2. That is the concept of Hill cipher. So first, I know it is very confusing, but you will hear all of the things. And the key. So that is about the plain text. And what about the key? Because key plays an important role in order to do the encryption process. So in the case of Hill cipher, your key is a square matrix. A square matrix of size m cross m. So when the Alice and Bob meets with each other in an area, in a space, then she and he has to decide what should be the value of m and what will be the key according to that. Key and the size of m, it has to be predetermined because we are talking about the symmetric key cipher in which all of the contents regarding the key has to be predetermined before doing the encryption process. So the Hill cipher says, so from this diagram you can understand more clearly. Hill cipher says that key is a square matrix of m cross m. So you can see over there it is m cross m matrix, and this is a block, plain text block, which contains P1, P2, P3 and so on, Pm, and the C1 will be generated by the multiplication of that K11 into P1. So according to that block, it has to be encrypted. So in that case, in the Hill cipher, it is not divided into equal parts of block. It takes all of the chunks of the plain text at a time. ठीक है, जितने भी chunks हैं वो सारे एक बार में ले रहा है, वो इसको पूरा एक ब्लॉक कंसिडर कर रहा है, उसको पूरा एक बार में encrypt कर रहा है. Then this process is repeated for the encryption process for generation of C2, such that the previous block encryption can make the contribution of another block. So for the K21, this matrix has to be, sorry, this one matrix, not this one. this one matrix have to be multiplied by this one, and C2 will be generated, and so on. So last one K1 से लेकर के Km तक जितना भी key है वो मल्टीप्लाई होगा मेरा P1 P2 से लेकर Pm तक, और मेरा Cm जनरेट होगा. So it is the case of multiplicative cipher in which each key has to be multiplied with the plain text value and generate the cipher text. So Hill cipher is the special case of multiplicative cipher. ठीक है? Because there is a multiplication process in the encryption algorithm. So according to the C1, P1, P2, P3 and P4, C1, C2 dot Cm will be generated. So the major point for the Hill cipher is the key, because as you know your key is, one second, your key is a square matrix and of size m cross m. And in the decryption process, what is the decryption process? Because it says it is an encryption one. In the encryption one, you have to multiply the key matrix value with the corresponding plain text values, right? Just like the multiplicative cipher. But you have to perform the matrix multiplication over there, because we are talking about the key matrix and the plain text. And for the decryption process, the scenario will be, what will be the scenario? The generated cipher text, like this one, will be multiplied by the inverse of the key matrix. So for this condition, such that the encryption and the decryption process has to be implemented in a successful manner, there may be one condition, that the key matrix inverse must exist. Inverse of the key matrix must exist, otherwise the decryption process will get failed. अगर इस की का जो भी आपने स्क्वायर मैट्रिक्स बनाया है, अगर उसका कॉरेस्पॉन्डिंग इनवर्स पॉसिबल नहीं है, उस मैट्रिक्स का अगर इनवर्स पॉसिबल नहीं है, then you cannot generate the corresponding plain text from the cipher text at the decryption process, because we are talking about the matrices. ठीक है, हम सिंगल एक वर्ड का बात नहीं कर रहे कि k का वैल्यू मेरा 15 है तो मेरे को k इनवर्स चाहिए, तो मेरे को निकालना है 15 इनवर्स एंड mod 26. मेरे को ये बात नहीं करनी. आई एम टॉकिंग अबाउट द मैट्रिक्स फॉर्म. So what is the condition to check that for the particular matrix inverse is possible or not? तो ये आप लोग पढ़ चुके हो in the first year, second year mathematics linear algebra. ठीक है, to check that particular matrix have inverse exists, we have to calculate its determinant. Okay, so by the calculation of the determinant, we can conclude the inverse of a particular matrix is possible or not. So what was that condition? तो पहले मेरे को लिख लेने दो, that inverse of key matrix must be there, otherwise decryption not possible. So due to this matrix feature, the brute force attack as well as the statistical attack is very difficult, or you can say impossible, over the Hill cipher because of this key matrix. Because all of the matrix does not have any condition that there should be exist of the multiplicative inverse, or you can say inverse of the particular matrix. तो सारे मैट्रिक्स का तो इनवर्स नहीं होता, कुछ ही मैट्रिक्स का होता है. ठीक है, वो क्या क्या मैट्रिक्स हैं उसको फाइंड आउट करना बहुत ही मुश्किल है. सो दैट्स व्हाई द ब्रूट फोर्स अटैक इज नॉट पॉसिबल ओवर देयर हिल साइफर, एंड यू कैन से देयर इज नो frequency catching over the generated cipher text. So that's why the statistical attack is also very difficult to implement over the Hill cipher. Okay, so what I'm talking about, that we have to check the determinant of the particular matrix. So if the determinant is non-zero, in that case, if the determinant determinant is non-zero, then we can say the inverse is possible. Otherwise, you can say the inverse is not possible. So take one example in order to understand more clearly. So suppose your plain text is A, C, and T, right? So this one is P1, P2, and P3, and your key value, because before the encryption process, Alice and Bob will meet to each other, and they will decide the key value as well as the value of M also. What is the value of M? Value of M will decide the square matrix size. And the key is GY, BN, QK, URP. Okay, and the value of M is 3. So this indicates the key matrix of size 3 cross 3. Okay. Now, if there is, so we have to position that key values over the 3 cross 3 matrix. So just give the positions G, Y, B, N, Q, K, and U, R, P. Now one doubt is over there, that suppose if the last value or the last two values are not filled, then what will be the case of 3 cross 3 and whatever it is? Then you can put the bogus character inside it. The bogus character is also decided in the meeting of Alice and Bob. कि मेरा first bogus character X रहेगा, second bogus character मेरा Z रहेगा. So according to that, the key will be generated. So in my case, all of the entries are filled successfully. So there is no need of bogus character in the key matrix. Now we have to check that this is the value of key because these are the characters. So in order to do some mathematical operation, we have needed some values, digit values. So we have to replace it by the corresponding digit values. So in the table, what is the corresponding value of G? That is 6. आप लोग चेक कर सकते हो, मैंने ऑलरेडी ये सब लिखा हुआ है तो इसलिए मैं डायरेक्ट लिख देती हूँ. So ये 13, that is 16 and 10, 20, 17 and 15. So these are the corresponding digit value of my key matrix. Now we have to check the inverse of that key is possible or not. So in the meeting of Alice and Bob, first they have to decide the key value and then the value of M. And also they have to sit long and calculate that which key matrix have inverse possible or not. If the inverse is not possible, then they have to choose some another key matrix values. Otherwise they can proceed. So first we have to understand that the key inverse is possible or not for this matrix. So check for the determinant. So in order to calculate the determinant, already आता है आप लोग को, that is 16 into, what is that? 15 minus 10 into 17, yes. Then minus 24, 13 into 15 minus 20 into 10 plus 1, 13 into 17 minus 20 into 16. इसको कैलकुलेट करेंगे. सो आएगा 420. So it is non-zero, so you can take as a key for the encryption process. So in order to do the encryption, we have to directly jump over the multiplicative cipher. What was the multiplicative cipher encryption algorithm says? It says in order to generate the cipher text, you have to multiply the key value with the plain text value. In order to generate the plain text, you have to multiply the cipher text value with the key inverse value. Okay, this is the encryption one, this is the decryption one. Now in the Hill cipher, we have to do it in the form of matrix. So because your plain text is nothing but ACT, so you have to fill it over the column wise. So that is 0, 2, and 19. And your key matrix is 6, 13, 20, 24, 16, 17, 1, 10, and 15. So just you have to perform the matrix multiplication. You can directly put over the formula. ये जो formula है कहाँ गया? This one directly आप put कर सकते हो. Otherwise you can perform the matrix multiplication row and column wise. Okay. So after the multiplication with key and the means this one will be multiplied by this one. ठीक है, इससे से करते थे ना मैट्रिक्स मल्टीप्लिकेशन में, वही सेम करना है, कुछ नया नहीं है इसमें. Then after this matrix multiplication, some values will be generated like 67, 222 and 319. So मैंने already करके रखा हुआ है इसलिए मेरे को पता है. तो 61, 222 and 319 will be generated. ठीक है, but you can note down this thing that after the matrix multiplication, it may be possible that your generated value may go out of range because your range is not exceed over 26, क्योंकि हम mod 26 का बात कर रहे हैं पूरे सिमेट्रिक साइफर में. ठीक है, सो मेरे को लास्ट में यहाँ पे अंडर रेंज लाने के लिए, फॉर मेकिंग इट अंडर रेंज, वी हैव टू परफॉर्म द mod 26 operation. So when we perform the mod 26 operation, the answer will be 15, 14 and 7. So that is my corresponding cipher text. Okay. So this is my corresponding cipher text. And the decryption process. What is the formula? The formula is we have to multiply the cipher text with the inverse of the key. So you have to first find out the inverse of that key. ये तो पता चल गया कि inverse इसका exist करता है, but what will be the value of inverse of that key? So it will be more complex क्योंकि आपको पूरा calculation करना पड़ेगा, ये बहुत लंबा process होगा. फिर सबको एक एक करके मल्टीप्लाई करके ऐड करके फिर डिटरमिनेंट से डिवाइड करके जो भी वैल्यू आएगा दैट विल बी योर इनवर्स. ठीक है, तो मैं यहाँ पे डायरेक्ट सोल्यूशन लिख रही हूँ, आप डायरेक्ट चेक, आप बाद में चेक कर लेना. क्योंकि लीडर अलजेब्रा का क्लास नहीं है, क्रिप्टोग्राफी का क्लास है. सो आई एम ओनली टीचिंग अबाउट द प्रोसेस, encryption or decryption process. So that is your generated cipher text I'm writing out, and this is your key, and we have to find out the inverse over there. So there are a lot of sites in the internet that from there you can find out the direct inverse of that particular matrix. So from there you have to put the key matrix values and they will give you the direct matrix values. So once we have multiplied over it, the answer is 260, 574 and 539 because these are out of range. So you have to perform the modulo operation, that is mod 26. So after perform the mod operation, the answer will be 0, 2 and 19. So it is nothing but the corresponding plain text value A, C and T. Now what will be the size of the key domain? The size of the key domain is 26 and the size of the square matrix, that is M cross M. But under this range, not all of the matrix have inverse possible. So find out which of the matrix having the inverse possible is a very difficult task for the attacker. That's why from the key size domain, the brute force attack is not possible, or it is very, very difficult to implement over the Hill cipher. Now I'm enabling the chat. If there is any query regarding the Hill Cipher, you can ask. And then I will start the next topic, new topic. Now the chat is enabled. You can write your doubts over there regarding the Hill Cipher. It is very simple. Just instead of the multiplicative cipher, we have to perform the matrix multiplication. That's it. And your key value should be in the form of matrix, a square matrix. Okay, so there is no doubt. So I will proceed to the next topic. And also in the coming Tuesday, that is 2nd of Feb. 2nd of Feb. Okay. So your monoalphabetic and the polyalphabetic ciphers are completed. Now we are talking about the transposition ciphers. These are the third category of the symmetric cipher. So what is a transposition cipher? As the name indicates, we have to transpose the positions over the plain text values. So according to that nature, they have in three types. The first one is we have to changing the position of the plain text values with the use of key. Second one is without key, and the third one is with key and without key, means mixed value. So this cipher does not substitute one symbol for another. Instead of that, it changes the location of the symbol. So it's not changing the symbols. It will change the location. Okay? So suppose if you have a string hello in the plain text, so it not says that H will be replaced by a particular word A. It is not saying. It says that what is its position 1, 2, 3, 4, 5. So it says that the first position value, that is H, will be replaced by the fifth position value. So it's changing or generating the cipher text according to the permutation of the positions. Not replaces the symbol, it replaces the positions. The cipher does not substitute one symbol with another. Instead of that, it changes the location of the symbol. So in that case, if the first position value is replaced by the fifth position value, so we can say in the cipher text, the position one will be replaced by the fifth one position. So it will be replaced by O. Second will be suppose replaced by fourth one. It will be replaced by L. Third will be replaced by first one. So it is H. Then fourth will be replaced by second one. It will be E. And fifth one is replaced by suppose third one. So it will be O. So this generated ciphertext will according to the changing of the positions of the alphabets. It does not replaces one symbol with another. It replaces only the positions. And basically we can say it reorder the symbols. It orders the symbols. Or you position the symbols. So we have three types. As I told you, the first is keyless, second is keyed with using key, and the third one is mixed one. First, we will learn about transposition cipher. So in the keyless transposition cipher, as the name indicates, there is no key used between the Alice and the Bob. So simple permutation is performed between the plain text value. And this permutation can be row wise, and the second one is the column wise. So there are two methods in order to implement this keyless transposition cipher. The first method says that text values of the plain text is written into a table column by column and then transmitted row by row. The meaning of that sentence is that whatever the text, whatever the characters inside the plain text, you have to write it in the column by column fashion and then read it into row by row in order to generate the cipher text. So let me write the text of the plain text is written column by column and transmitted, or you can say, in order to generate the ciphertext, it is read row by row. Now the second method. The second method is the reverse of first method. Simple. In the second method, the text of the plain text, or you can say the alphabet of the plain text, is written row by row and transmitted, or you can say in order to generate the ciphertext, it has to be read by column. Okay, so I'm not writing over there. So the most commonly known keyless transposition cipher is called rain pen cipher. So the rail pen cipher says that, one second. Hmm. So in the rail pen cipher, it says the alphabets of the plain text must be arranged in two lines in the zigzag fashion, means column wise, because we are talking about the first method. So it will take, according to the first method, alphabets, or you can say text values, are arranged in two lines as a zigzag fashion, means column wise. तो zigzag कैसे होता है, ऐसे 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 होता है ना, तो ये कॉलम वाइज है, ठीक है, ये एंड देन ऊपर, देन नीचे, देन यहाँ पे, फिर यहाँ पे, फिर यहाँ पे, ठीक है, so means column wise. And the cipher text is generated by reading the text row wise because we are talking about the first method. And cipher text is generated by reading the text row wise. Example, theory चल रहा था, अब example देखते हैं. For the encryption process, because there is no key used, so there will be no meeting will be performed between the Alice and the Bob. ठीक है, so just they have to agree over there that they will use rail fence cipher for the encryption and the decryption process. So for example, the plain text is meet me at the park. So we have to encrypt it by using the rail fence cipher. So rail fence cipher says that alphabets of the plain text. What are the alphabets? M E E T M E A T T H E B A R K are arranged in two lines as a zigzag fashion. So zigzag fashion में भैया arrange करो. ठीक है, ये यहाँ पे मैंने डाउनवर्ड से शुरू किया है, अपवर्ड से भी शुरू कर सकते हो. इट्स ओनली अपॉन योर कॉल. ठीक है, तो मैं कॉलम से स्टार्ट कर रही हूँ ना, कॉलम वाइज है मेरा. सो कॉलम आपका ऊपर से नीचे स्टार्ट होता है, नीचे से ऊपर स्टार्ट नहीं होता. So that's why I'm taking like this way. तो ये zigzag fashion में है. It is like the zigzag fashion. So M and the zigzag will be like this one. Then the column will be this one. Then this one. Meet me at the park. So you can see over there, this is a zigzag fashion in the column wise. ठीक है, तो अगर आप स्ट्रेट में लिखो तो स्ट्रेट में कैसे आएगा, ऐसे आएगा ना, MEET, ठीक है. बट in the rail fence cipher, we have to transmitted it. Sorry, we have to write it in a column wise. Yes, it is column wise, but instead of a straight line, we have to perform it. We have to do it like a zigzag fashion. So that's why this M is shifted over there in the middle of two. Now the cipher text. This is a plain text. So in order to generate the cipher text, what the algorithm says the cipher text is generated by reading the text row wise. So we transmitted the plain text into the column wise and we have to read it row wise. So what is the row wise? First we have to read that row, then we have to read that row. So M E M A T E A K. This is the first row. What is the second row? E T E T H P R. And this is your cipher text or the corresponding plain text by using the rail fence cipher. Now what about the decryption process? अब encryption तो बढ़िया हो गया, But in the cryptography, we have to make sure that the encryption and the decryption process must be inverse of each other. Otherwise, the plain text will not be generated and there will be no use of cryptography in that case. So that's why we have to perform the decryption process also. So the rail-pen cipher, the encryption process is this one, and the decryption process of the rail-pen cipher is that Bob receives the ciphertext, this one, MEMTEKTETTNSPKR, and it divides this ciphertext into the two halves, okay, two equal halves. So Bob will receive the ciphertext and divide it into two equal halves. Now the case is, suppose the length of the ciphertext string is not divided by 2. Suppose इस केस में कितना है 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, this is one of the example. So in that case, the length is odd. It is not divided by 2. So in that case, the dividing of the ciphertext into two equal halves is not possible. In this scenario, you have to generate two halves. In the first half will carry one more character and the second half may carry one less character. तो ये 15 था, so 15 1 2 3 तो फर्स्ट हाफ में 15 का था, कितना हुआ 7 point something. तो मेरे को 8 फर्स्ट हाफ में ले जाना है और बाकी बचे जो 7 हैं वो मेरे को सेकेंड हाफ में ले जाना है. सो मेरा 8 यहाँ पे कहाँ खत्म हो रहा है 1 2 3 4 5 6 7 8. And this will be the second half. So it is first half and this is second half. So after receiving this ciphertext, the Bob will divide it into the two equal halves. If it is not divided by 2, then the first half will contain one more character and the second half will contain one less character. After that, once it is divided, then it has to write these two halves into strictly two rows. क्योंकि मैंने टू हाफ में इसको डिवाइड किया है, सो स्ट्रिक्टली मेरे को टू रोज में ही इसको लिखना पड़ेगा, बिकॉज वी आर नॉट यूजिंग एनी की, बिकॉज दिस इज अ कीलेस ट्रांसपोजिशन साइफर. तो चलो भाई लिखते हैं टू रोज में. सो माय फर्स्ट रो इज एम ई एम ए टी ई ए के. सो माय फर्स्ट रो इज कंप्लीट. फर्स्ट हाफ मेरे फर्स्ट रो में जाएंगी, सेकेंड हाफ मेरे सेकेंड रो में जाएंगी, because we are talking about the rail-pen cipher in which we have to read the message in the encryption process zigzag fashion. So at the decryption process, we have to again write it in a zigzag fashion. So second half will be in the zigzag fashion, like E, T, E, T, H, P, and R. Okay. Now read it column wise. तो डिक्रिप्शन प्रोसेस में मेरे को रिवर्स करना है. वी हैव टू परफॉर्म द रिवर्स प्रोसीजर इन द डिक्रिप्शन. इन द एन्क्रिप्शन प्रोसेस मैंने क्या किया था, इसको कॉलम वाइज लिखा था और रीड किया था इन द रो वाइज. ठीक है. एंड फॉर द डिक्रिप्शन प्रोसेस वी हैव टू write it in a row wise and read it in a column wise. So मैंने row wise इसको लिख दिया है और मेरे को column wise इसको मतलब पढ़ना है. ठीक है. So column wise जब मैं पढ़ूंगी तो क्या आएगा मेरा plain text? That will be the first column MEET MEAT ऐसे ऐसे जाएगा ना. Then THE and PARK. So this is the corresponding plain text, meaningful plain text generated from the ciphertext by using the real pen cipher. Now the attack is very easy because the Eve knows that there is no key used between the Alice and the Bob. Okay? If there is no key used, then only the knowledge of the encryption algorithm, that is the real pen cipher used by the Alice and the Bob, is enough in order to perform the attack over the generated ciphertext. अगर उसको साइफर टेक्स्ट मिल जाता है और अगर अटैकर को पता है कि रियल फैन साइफर ही यूज हो रहा है बिकॉज ऑल ऑफ द साइफर्स आर पब्लिक इन नेचर ना, ये मैं बता चुकी हूँ कि सारे साइफर्स मेरे पब्लिक होते हैं, सबको पता होते हैं. You have to hit and try. Being a attacker, you have to perform the hit and try procedure. So first, after the additive, multiplicative, append cipher, Hill cipher, Vignes cipher करने के बाद अगर उसको meaningful text नहीं मिलता है, then the attacker will perform the real pen cipher over there, and he knows that there is no key has to be used over the real pen cipher. Then it has to transmit it row by row and read it column by column, and the meaningful plain text will be generated. So attack is very easy over the real pen cipher. अभी तक डाउट इसमें किसी को? Okay. So this is the first method under the real pen cipher. Now the second method of transposition cipher, keyless transposition cipher. So in the second method, Alice and Bob will have to meet. Okay, meet with each other in a CCD or KFC. Then Alice and Bob will decide the number of columns. And Alice write the plain text row by row and creates a ciphertext by reading the column by column. Because second method में क्या होता था कि मेरे को row by row read करना है, okay, for the plain text. And in order to generate the ciphertext, we have to read it column by column. So for the second method, Alice and Bob will meet to each other. And decides the number of columns. सपोज एलिस एंड बॉब ने मीट किया और उन्होंने कॉलम जो है वो डिसाइड किया कि कॉलम का जो नंबर होगा वो 4 होगा. वी हैव टू यूज अ नंबर ऑफ कॉलम्स, 4 नंबर ऑफ कॉलम्स. ओके, so 1 2 3 4. The plain text message is saying that meet me at the park. So just in order to generate the plain text, write over there row by row. So meet me at the park. So this is the plain text. And what will be the corresponding ciphertext? The corresponding ciphertext says that you have to read column by column. So column by column read column. M T A E E H R E, A, E, K, and T, T, P. This is our ciphertext. Now, what about the decryption process? So, in the decryption process, क्योंकि मैंने रो बाय रो परफॉर्म किया था, so मेरे को कॉलम बाय कॉलम यहाँ पे परफॉर्म करना है पहले राइटिंग. तो नंबर ऑफ कॉलम्स इज 1 2 3 4. सो मेरे को कॉलम बाय कॉलम लिखना है और इसकी रो भी मैं फिक्स करूंगी 4 से ही. सो एम एम टी ए ई ई एच आर, ये साइफर टेक्स्ट लिख रही हूँ मैं. देन ई ए ई के, देन टी टी पी. तो कॉलम वाइज मैंने लिख दिया, मेरे को रो बाय रो जो है वो रीड करना है. सो दिस इज माय ciphertext, and what will be my plain text? Row by row reading. So M E E T, meet me at the park. That's it. So it is very very simple. बहुत ही अच्छा भी लगता है पढ़ने में, ज़्यादा दिमाग लगाने की जरूरत नहीं है. जस्ट अगर कॉलम वाइज आपने राइट किया है तो रो वाइज रीड कर लो, रो वाइज राइट किया है तो कॉलम वाइज उसे रीड कर लो in order to generate the ciphertext. ठीक है. So this one, the second method is also very much easier to implement by the attacker in order to generate the plain text, because the attacker must know the number of columns. So if the attacker must know the number of columns that is predetermined by the Alice and the Bob in the second method, then the attacker can decrypt the ciphertext, the corresponding ciphertext. And what will be the maximum number of column in that case? The maximum number of column will nothing but the length of the ciphertext. ठीक है, कितनी लेंथ का है? 15 लेंथ का है, तो 15 ही हमारा टोटल जो है वो कॉलम हो सकता है. अगर वो 15 ही कॉलम ले लेगा तो एक ही कॉलम में सारे आ जाएंगे, राइट. सो 15 से ज्यादा नहीं हो सकता. सो इट द अटैकर हैज टू मेक द इटरेशन ओवर 1 to 15. So it is very very prone to the brute force attack, because the key size you can see over there, the number of columns is nothing but maximum 15, can be 15, means length of the ciphertext, or you can say length of the plain text. So from intercepting of the ciphertext, the attacker will get to know the length of the ciphertext, and according to the length of the ciphertext, it has to permute the columns. ठीक है, हर बार उसको कभी 2 लेना है, 3 लेना है, 4 लेना है, 5 लेना है, उसके अकॉर्डिंग वो परम्यूट करेगा. Then it will decrypt the cipher. So it will be very very easy for the attacker to know the number of columns from the ciphertext length, and the attack can be possible over the relevant cipher, transposition cipher. So it is all about the today's lecture. If there is any doubt, you can write. I will explain. Otherwise, you can leave the meeting.